morning all of you. Now I am going to discuss different types of errors. So first of all, what is an error? Error is nothing but it is the deviation of measured quantity with the true quantity is called the error. That means error is equal to measured value minus true value. That is the error. And now we shall discuss about different types of errors. So different types of errors are classified into two types. First one is static error and the other one is dynamic error. So coming to the first one, what is the meaning of static error? So static error means it is the difference between true value of the variable and the value indicated by the instrument. That means it does not vary with respect to time. So this is a constant error. So it is the difference between the true value of the variable and the value indicated by the instrument. It is called the static error. So the static error is again classified into three types. Those are first one gross errors, second one systematic errors, third one is random error. Again, the systematic errors are classified into instrumental errors, environmental errors, observational errors. Coming to the first one, gross errors. So gross errors means errors are because of the human mistakes. That means the person who is taking the readings are responsible for this type of errors. So that means if he is negligent while taking the reading, then these errors will happen. So what are the different methods to minimize this gross error are? First one is the reading should be taken very carefully. So that means while taking reading, you should be very conscious about taking the readings. And second one is two or more readings should be taken of the measurement quantities. So instead of taking depending on only one reading, he can take two or more readings so that he can know where the first one is error, there is an error or not. Okay, next one, systematic errors. In the systematic errors, there are three types. In that first one, instrumental errors. So instrumental errors means it is because of the instrument only, that is inherent shortcomings of the instruments. So while manufacturing itself, there is some amount of errors happening. So because of that, while we are getting the instrument from the manufacturer itself, there is some error, there is some damage problem or like that. So that because of that, you will be getting this type of errors. Next one is misuse of the instruments. That means if you are using one instrument for other experiment, suppose take for example in our lab, if you are using 10 amperes ammeter to a is in a circuit where you are using 20 amperes or less than 10 amperes like that if you are using, sometimes because of that also there is some amount of error. That is exact reading it will not be able to show. So that is misuse of the instruments and loading effects of the instruments. That means if you are highly loading, that means in one experiment you are using, and if you want to use the same for the other different types of different experiments, and if you are loading it, if you are using it more frequently, then this type of errors will be happening. And these errors, how you can going to minimize are, these errors can be minimized by selecting a suitable instrument for a particular measurement. So that means only one instrument is used for a particular measurement. You should not replace that instrument for other purpose. So that is by that way you can reduce these errors. And also if you apply correction factors after determining the amount of error. So that means if you first determine the correction error and how much difference it is there if you find, and if you use that instrument wherever you want and add or subtract that error, you will be getting the correct reading. So by this is called correction factors. Applying correction factors after determining the amount of error. The second one is environmental errors. As the name itself indicates, these errors are due to the environment, that is external condition, are due to the external condition of the measuring devices. External condition means those are temperature, effect of temperature, pressure, humidity, dust, vibration, or because of the magnetic or electrostatic fields. So because of this, you will be getting these environmental errors. So that means vibration also you will be able to note some error. So that means if vibration, big machines are rotating, then some amount of vibration will be there because of that error vibrations also. You will be getting these environmental errors. Next one, these errors, how you are going to minimize these environmental errors are, these can be minimized by air conditioning using magnetic shields. If you use the air conditioner, that means it is not dependent on the outside temperature. So like that you can also use magnetic shields so that any magnets nearby will not be able to have an effect on the pointers. So like that you can minimize these errors. And the third one is observational errors. So observational errors means while taking the readings, if you are taking the reading and if you are at the edge of the table and if you are noting down the reading, then in that cases that you will be getting the parallax error. While taking the reading, you should be uh, in front of the instrument and you should take the reading exactly. So these errors can be reduced by high accurate meters and provided with mirrored scale. So that mirror, under the pointer there is a mirror, so that the pointer and the mirror if they coincide, then parallax error will be reduced. So like this you can reduce the observational errors. And the third one, last one is random errors. So random errors means these are caused because of no particular reason. Because of these errors, you could not be able to identify what is the reason for this type of errors. So these are called random errors. So these errors can be reduced by increasing the number of observation. If you take more readings instead of taking one reading, if you take more readings and if you apply some statistical methods, you will be getting you can be able to reduce these random errors. We can discuss this in the next topic itself, coming topic. Increasing the number of instruments. So that to reduce the random of errors, we can use this statistical analysis of random errors. So what is the statistical analysis of random errors? So as we already discussed, random errors cannot be determined in the ordinary process. We don't know what is the reason behind these random errors. So we will not be able to determine the ordinary process of measurement. So these errors, how you can reduce these errors means these errors should be first treated mathematically, and by applying some mathematical analysis, you can be able to reduce the error. For that, what are the different mathematical errors? Mathematical analysis are in the lower classes you might be heard about the mean, median, like this. So we shall discuss now. Those methods are useful for the statistical analysis of random errors. In the first one, arithmetic mean and median. So what is this arithmetic mean means? So if you know, if you are taking readings, suppose you are taking n readings, that is x1, x2, x3 and so on xn. Suppose n readings you are taking. So mean is nothing but the sum of all the readings divided by number of the readings. So sum of all the readings divided by number of readings, you will be getting the arithmetic mean. So that x is equal to, this sum is denoted by sigma, that is equal to 1 to n and x of xn divided by n. That is about the arithmetic mean. And median means if you arrange all the readings, suppose n readings you have taken, that n readings you are arranging those n readings in ascending order, and if you take the exact mean, that is middle of the readings, that is xn plus 1 xn plus 1 is the middle reading divided by 2. So by if you by make it divided by 2, you will be getting the median. So that is also by using this also you can reduce the statistical errors. Next is by using the deviation from mean. So deviation from mean means we know that x is nothing but the arithmetic mean and xi is the value of the ith reading. Then how you are going to get this deviation from mean means deviation is denoted by the letter di. Di denotes the deviation. So di is equal to xi minus x. Xi is nothing but the arithmetic mean minus xi is the ith reading minus arithmetic mean will give you the deviation. And standard deviation means it is denoted by the letter sigma, and it is nothing but the square root of sum of all the deviations by number of readings minus 1. So as we told that deviation is nothing but the specific reading minus the mean. So here D1 indicates the first reading value minus the mean value whole square. Likewise, second reading second reading value minus the mean whole square. So like that. So how many readings you are taking? So that many number of deviation from means are calculated and square all the readings divided by number of readings minus 1, and you will be taking the square root of all the readings. So this is nothing but the standard deviation. So by using these methods, you will be able to, these are nothing but the statistical analysis. By using these methods, you will be able to reduce the random errors. So what are the different statistical methods are? Arithmetic mean, median, next one is deviation from mean, and next one is standard deviation. So these are the statistical analysis of random errors. Coming to the next topic, it is nothing but signals and their representation. So first of all, what is a signal? What is a signal means signal is defined as any physical quantity or parameter varying with respect to time. So any quantity which is varying with respect to time is called as a signal. So here you can observe this is on x-axis you are taking time, and t is the variable here. If the variable is varying with respect to time, then it is called a signal. And how you are going to classify these signals? So these signals are classified into two types. One is continuous time signal, and the second one is discrete time signal. Continuous time signal means if the variable is varying continuously, there is no break here. In this graph you can observe there is no break in the graph. It is continuously varying with respect to time. This is called the continuous time signal. And coming to the discrete time signal. Discrete time signal means if x of here, x of n is the variable and n is taken on the x-axis, this xn is nothing but the uh, xn is nothing but the variable which is varying, it is not varying on time, but it is varying with the variable n. And for n point, for each specific n point, you are getting the value. But this is not continuous. There is, you can observe in this graph, there are breaks. These are nothing but discrete time. It is there. So these are called discrete time signal. So these both the continuous time signal and discrete time signal are classified into four types. Those are nothing but first one periodic and non-periodic signals, second one even and odd signals, third one energy and power signals, fourth one deterministic and random signals. Coming to the first one, periodic and non-periodic signals. So what is the meaning of periodic? Periodic means specific amount of time. So suppose here you can consider 0, this is t by 2 and this is time t. So from 0 it is coming here, and from t by 2 it is reaching 0, and after t by 2 it is going into the negative axis, and t it is getting 0, and after that it is going to repeat again. So from 0 to t, time period to t, it is getting repeated again. So that means this signal is said to be periodic if it repeats at regular intervals. At regular intervals, if it is going to repeat, here also you can see this is the time period t, and after time period t again you are getting another signal. So that means this is a periodic signal. Here also you can observe from for a time period t it is sawtooth waveform and it is reaching zero. After again t again it is increasing and it is again reaching zero. Like that for a time period t it is going to repeat. And you can observe this is a continuous wave. There is no breakage here. So these signals are called periodic continuous signals. Periodic continuous signals. And likewise, you can also indicate non-periodic signals also. Under periodic, you can have the continuous periodic and also discrete periodic. So these two are the periodic, continuous periodic. Likewise, you can take discrete periodic also. That means suppose there is a signal here and there is another signal here and another signal here. That means these three are repeated for a time period t, but there is no continuity here. Continuity means connection between the two readings. So that those are called the discrete periodic. And here you can observe from 0 to time period t, only one signal is there and after that it is not going to repeat. So this means this is an example of non-periodic signal. This is an example of non-periodic signal. So these two are examples of periodic signals, periodic continuous signals, and this is an example of non-periodic continuous signals. Okay, this is about the first one, periodic and non-periodic signals. Next one, even and odd signals. What is the meaning of even? So that means even means generally in mathematics you can say what is even. Even means multiples of 2 are called even and other than multiples of 2 are called the odd. So that means likewise here also a signal is said to be even if inversion of time axis does not change the amplitude. Even signal also are called symmetric signals. Suppose x of t is a function which you are taking here. In place of x of t, in place of t, if you replace with minus t, then you are getting the same value, then it is called a even signal. So if you get in place of x of minus t, you are getting minus x of t, then it is called uh, odd signal. Suppose take for example, for even signal you can consider cosine function. So suppose cos t you are taking, cos t is the signal here. Instead of cos t you are placing, in place of t you substitute with minus t. So cos of minus t is also a cos t only. So that means if you replace the time with minus t also, you are getting the same function. So that is called the even signal. Example of odd signal is nothing but sin t. So in place of t, if you substitute minus t, then you are getting the minus sin t. So minus of the function you are getting. So that is called the odd function, odd signal. Likewise, t square can be considered as even signal and t cube can be considered as odd signal. So likewise, these are some of examples of even and odd signals. Okay. Next one, energy and power signal. So what is this energy signal? So a signal is said to be an energy signal if and only if its total energy is finite. Its total energy is finite. That means you know the value if you are able to know some exact value of energy. That means you cannot say it is depend on some other variable like that. So from her exact value, if you are able to determine, then it is called the energy signal. For an energy signal, the average power P is equal to 0. So here the power average power, if you consider, P becomes 0. The non-periodic signals are examples of energy signals. So those signals which are non-periodic are considered as energy signals. And power signals means power signals are nothing but here the average power is finite here. Energy for energy signal, average energy is finite, whereas here average power is finite. And here for total energy is equal to infinite here. Here the average power P equal to 0. And the examples of power signals are the periodic signals are the examples of power signals. Okay, these are nothing but energy and power signals. Next one, deterministic and random signal. As the name itself you can say deterministic. Deterministic means you you know the correct value. That means it is nothing but deterministic. So a signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time. Or signals which cannot be defined exactly by mathematical formula are known as deterministic signals. And a signal is said to be non-deterministic if there is uncertainty with respect to its value at some instant of time. And non-deterministic signals are random in nature, hence they are called random signals. And for these random signals, you will not be able to give any mathematical formula. So these are nothing but deterministic and non-random signals. So these are the different types of signals. So what are the different types of signals? So those are four signals are there: periodic and non-periodic signals, even and odd signals, energy and power signal, deterministic and random signal. These are different types of